Merhaba arkadaşlar, hoş geldiniz. Bugün Jack İstanbul bünyesinde bir etkinlik daha gerçekleştiriyoruz. Bildiğiniz gibi geçen haftalarda Java 9 to 14 serisini tamamlamıştık. Bugün de Nicolas farklı bir konu üzerinden bir etkinlik gerçekleştirmek istediğini belirtti bize. Biz de bu fırsatı değerlendirmek istedik ve bu etkinliği gerçekleştirdik. Birazdan sözü Nicolas'a vereceğim. Okay, Nicolas, we are glad to have you. So this topic is very interested for us. So you can start your presentation.
Teşekkürler. Selam millet. Adım Nicolas Frankel. And yeah, that's a lot for me already. I can talk to you about food, but this conversation will be in English because I cannot do better the rest. Let me share my screen. Hello. Is it good? Do you see my screen now?
It's good. Yeah, you can start.
Okay. So thanks for having me here for this talk about an experiment in continuous deployment of JVM application. I'm Nicolas Frankel. For like 20 years, I've been a developer, team lead architect. I've been a technical guy. A couple of years ago, I've switched. I forked my career path. I decided that I had enough to work for customers, to have projects, to have deadlines, to have middle managers. I've decided that was enough for me, so I went to be the developer advocate. So now I'm the code I'm writing is for fun. I have no deadline, and I hope that you will like what I present you tonight, because this really is like, let's say, crazy, or in better terms, like creative idea of different technologies that I happen to have used already. I work for a company called Hazelcast, so I guess if you are from Turkey, a lot of you already know about Hazelcast because our main development office is Istanbul. Hazelcast provide two products. The first one is called IMDG, and IMDG, basically, you can think about it like a distributed data structures, and the most use of this data structures is the hash maps. So basically, you can have an API that allows you to do the kind of stuff that you do with regular map in Java, but behind the scene, everything is distributed. So if one node fails, then you still can keep the rest of the data, and then you can have replication, and everything is handled for you. The other product that we offer, our newest offering, is called Jet, and it's the stream processing engine that works in memory. And perhaps you know, I mean, I hope that you know about continuous integration. Continuous integration has been used for perhaps 15, or perhaps even in some company even more. You have all those steps that every commit you do, then your code is compiled, then you run the unit tests, then you probably have some packaging. Once the package, which might be a war, might be a jar, might be anything, then you've got some more integration testing to work to check out that not only the teeny bits and pieces work separately, but the whole package works as a whole. So once you've got your package that has been built, you want to do some integration testing, and perhaps afterwards or before, the package is a container. And then once everything is done, whether you have a container or a regular jar, then you store it in the registry. I mean, that's the whole history of continuous integration. And as I mentioned already, I hope that all of you does it. Perhaps not everything, but does it. Like you're using Jenkins, you're using anything else. But the important is that every commit triggers this build, and then you can fail fast if something has gone wrong. Now, this is what I expect you to already do. However, the continuous stuff is not only about continuous integration, but there is also this continuous delivery. So instead of just like checking that everything is good and building the package and storing it, you also like deploy it to production, or at least you are ready to deploy it to production. You just make sure that once it's ready, then the business must give the go and say, hey, yeah, I agree to deliver it to production. And it's much harder to do, because now it's not only about storing it, it's about like deploying it, delivering it to the production environment. And finally, you have this continuous deployment philosophy, which means that there is no manual intervention, there is no business involved, no business decision. You trigger your build by committing, and then magically after some time, then you've got the package delivered and deployed into production. And if you have worked for big companies, that's how Facebook, for example, works, or how Google works, and they cannot just every time have a business person saying, yes, I agree to that, or I will test manually. Everything is deployed. Of course, it's deployed like in a very small subset. For example, I know that Google first deploys internally to all its employees. So if there is a bug there, they are the first line of beta testers. Then afterwards, they do a canary release. They will say, oh, we will like deploy it to like 10% of our customers, and then they increase it until it reaches 100%. And when you are doing that, then there is something that you must do at all costs, is you cannot have downtime. It's not okay. So we must not have any downtime. I mean, downtime is really not great at all, because it means that you must stop your application, and during the time when you stop your application, your customers cannot access the application. If you have internal customers like employees, it's not great, but I mean, they have no choice. But if your software, for example, is an e-commerce shop, and every day or every week you must have downtime because you are releasing a new version, that means that during that time your e-shop is not accessible. And when people are not able to access your shop, they will access your competitor's shop. And you don't want that, because you want to sell at all costs. That's the point of e-commerce. You want to sell all the time. And the problem with the JVM is basically the traditional JVM deployment model is exactly that. You start the JVM, you copy paste your jar or your war, and you start the JVM again. And during that time, you have not access to the application. So that's not great. So this is a model that has been like already described some time ago. Then this is the BlueGreen deployment. So basically you have this production, and which is the green, the above environment. And when you want to deploy a new version, then you have like a completely similar environment called the blue environment. So you put your new software on it, and at some point you say, okay, I will just say, hey, I will just point this like arrow on the top to the arrow on the bottom, and then everything is magical, and I don't need to have downtime. However, there are a lot of issues with BlueGreen deployment. The first thing is, like, here it can be instantaneous. I can just snap my finger and all my users will be using the new environment. But of course, in reality, it doesn't work like that. Like at some point, people might still be redirected to the green environment, which is not the production anymore. The second issue is, what are you doing with people who were using the green environment, and you need to switch them to the blue one? I mean, they still have like states on the green environment. So if it's state on the app server, it can be like sessions, for example. They can be migrated. That's more or less okay. But then the database, it's a very big mess, because it's not possible to copy every piece of data from the green database to the blue database. So in general, when you do this blue-green deployment, you have one shared database, but then the problem is, how do you deploy a new schema, a new database schema on a shared environment? Then it becomes a mess. Like, I have another talk that describes it. You can do it, but it's very hard to do. Of course, Kubernetes, because if you have been using Kubernetes, I hope the screen is refreshed now. Can I get, yes, good. If you've got a Kubernetes, then Kubernetes will save your life. That's what they tell you, that, oh, you just do rolling upgrades, and then you can just like node by node refresh the application to a new version, and it will handle the downtime. And it's true, but you still have the problem of the database. It doesn't handle the state as easily as the app. And so we are stuck with those options. They are very hard options to manage, because, again, the problem is the database, and it's very hard to do that. But what if I told you that you could change the bytecodes inside the JVM with no downtime? That would sound a lot like magic. However, I in this presentation, that's what I'm going to do. I'm going to prove you that magic exists, that there are unicorns, and you are right to believe in, I don't know, like anything that you believed when you were a child. But it still relies on some technical features of the JVM. The first one is called the attach API. So in general, not a lot of people know about the attach API. And the attach API allows you to do something very interesting. It allows you to load an agent inside another running JVM. So you have one JVM, let's call it A, and you spawn another JVM, let's call it B, that sends these agents to the first one, to the A one. And the funny stuff is, you don't need to run any bugs. You don't need to open all your ports or whatever. You just like run this B JVM into the same system as the A JVM, and because it knows the PID of the A JVM, then it can do this like dynamic loading. The attach API is actually very, very simple. Again, tell me if that slide doesn't refresh, because then I will need to do some like refreshing myself. Here I show like a UML diagram of this attach API, and what you can see is it's very simple. You have this abstract virtual machine, and basically it relies on an implementation that it's not very important, but basically you have this attach static method where you pass just the ID of the PID of the new machine, and it's done. And then afterwards, you load the agent, and you need to pass the path to the agent.jar on the file system. And perhaps you don't know about Java agents. And actually, a Java agent is just a simple jar with specific metadata. It's normal jar, but you have in the manifest.mf you have like additional, or let's say specific key value pairs. It's part of something called the instrumentation API. So it's another API, and this instrumentation API allows you to change the bytecode of running application. So with the instrumentation API, you can change the bytecode of running application. With the attach API, you can do that, like take the agent and put it dynamically. And then with both, we can do everything. Just as a word of caution, you have two kinds of agents. In general, people know a lot about these static agents kind of stuff, because when you do monitoring, that's exactly what you are doing. When you say Java-jar-Java agent and pass to an agent, that's exactly what you are doing. A lot of of monitoring tools, they work like that. So at the beginning, at the start of the JVM, you set the path to the agent. And afterwards, then when you like run my jar, then the agent jar might act upon the bytecode. But with the attach API, you can also do that dynamically. So you start a JVM which has no agent, and you start a new JVM that will attach the agents to the first one. Those metadata are very, very similar. In fact, it's possible to have a jar that is both like an agent jar that is both dynamic and static, because on the entering point of a static jar, you have a method called pre-main, and the entry point of a dynamic agent jar is called agent main. And you see that they look very, very similar to your normal main method. The only difference is this instrumentation interface that will be passed by the JVM, and that's this object that we can leverage. And in the metadata, in the manifest.mf, you will have this premium class of this agent class that will point to the class that has this pre-main or agent main. Instrumentation has two different features. The first is we can change the bytecode of a running class, of a class that has already been loaded. So we can like reload it with some changes. Of course, there are limitations. Not everything is possible. And also we can do some automatic transformation of bytecode. So basically when the class is loaded, you can ask the instrumentation to always apply some kind of transformation. And this is the instrumentation API UML diagram. So this is what will be passed by the JVM. And here, what we will be interested in is this method called Redefine classes, which takes a class definition. What I mentioned just before is like these add transformer stuff. This is something additional that we won't need, but you can do it anyway. If you're interested, you can dig further. And this class definition is just a class, like a class name, with the byte array, the bytecode representation of the class itself. So if we have access to a class, a dot class, if we can read the file, if we can read the bytes from the file, and we can put that in a byte array, and we have a class as in the class Java class, then we can transform what was, we can reload with this new byte array bytecodes the same class. And that's what we'll be doing. So what we only miss right now is an option to move the bytecodes around. And like moving data from one place to another place, you basically have two different ways. Either you are doing batching, and batching means we move like a limited set of data at regular intervals, at regular frequency, and you probably have been using batching all your life, saying, hey, let's say, for example, in banking, we will batch the data that is internal to our systems, and we will like take the data from inside of our system to a database that is accessible by the customer, and this runs every day. So basically, that's the reason why most banking systems you have from your application, you can see only your balance for the day before. That's because it runs every day. Another option to move a data from point A to point B is to do streaming. And streaming is exactly what you have been doing with Java 8 streams. Is basically, it's an unbounded stream of data, meaning that as soon as you get new data, then you push it. So if there is no data inside the stream, nothing happens. As soon as you've got data, then it gets pushed to the other end of the stream. There are a lot of like in-memory stream processing engines. Actually, there are some on the clouds. There are also some on premise. you've got, for example, you might know about Apache Flink. What I will be showing is Hazelcast Jet because I'm employed by Hazelcast, but you can use anything. You might also be interested in Apache Beam, which tries to be an abstraction layer over like specific implementation. However, just be careful because it's not the standards, and then there were many different implementations. It just tries to like unify all capabilities of existing stream processing engines. So basically, it's a very, very keen abstractions. However, I think it's interesting anyway. And regarding Hazelcast Jet, is an open source, like Apache 2 open source license. It's a single jar. So basically, it can be used as a library or as a dedicated image. So basically, either you can use it inside your own application, and then it scales with the number of application, or you run it on a dedicated place, and then you can scale independently. Of course, there are two different ways of doing that. Some have benefits, some have downsides. If it's easier if you embed the jar by yourself, but regarding production usage, it's better if you have this client-server way of doing stuff. Anyway, Hazelcast has an API that allows you to do either batch of streaming under a unified API, which is interesting. And we have a lot of like out-of-the-box what we call sources. So basically, you can read data from Kafka, from your IoT device, from Hazelcast IMDG, from the file system, from a socket. We even have like an integration with the Debezium, which lets you read database events. So basically, you might know about change data capture. So when you have an update or an insert into your application, the problem is the database only knows about the current state. But perhaps you are interested about the events themselves and not every time polling the database to know what has changed. So this is what the Debezium does, and the Debezium is a change data capture engine, and you can leverage the Debezium inside of Jet to read those database events. And on the other side, the targets, they are the same. You can have Kafka, you can have IMDG, you can have a database, you can have file system, you can have anything. And inside, if you have been doing batches already, I mean, you know all about this kind of stuff. So you can like get data from point A on the left side, then you transform it, and then you write it on the other side, on the right side. And this is what probably you have been doing by batching here. Again, you can do it without interruption, just by registering some sources and like saying, hey, I will write there. As soon as something happened on the left side, then it gets written on the right side. And then meanwhile, you can do transform, filters. I mean, whatever you can do with Java 8 streams, you can do with Hazelcast. The only difference is that it's distributed by nature. So now that we have the big picture, we have everything that is set in place, we can try to see how it works. So here, I will have my like source class, and every time I do a compilation, this source class will get updated. And I have this JVM, the streaming JVM that runs my Jet job. This Jet job will like observes this class. So every time it is changed, it will put it in Hazelcast IMDG. You can put that in the database. Here, I prefer it to be in memory because it's easier, but you can do whatever you want. Then I have this production JVM that runs, and that runs the same source.class as this one. And when it starts, it will be completely self-contained, nothing happens. But then I will run this injection JVM that will attach the agent jar on this production JVM. And once I have done that, then this production JVM, this app, will like also observes this Hazelcast EMDG map. So when the Jet job updates the map, then the app will be triggered, and it will be able to reload the new bytecode. So if I do the flow, this is something like that. I have this jet job, and like it will loop to read the source class. If it detects a change, it will put the bytecode into the Hazelcast map. And then I have these load agents that will attach itself to the production JVM to subscribe the production JVM to the Hazelcast map. And then it will read the bytecode, and every time it will reload the new bytecode. Is it clear, or do you have questions?
Does the API cause any performance problem because of runtime process when class which is under streaming operation is used from JVM?
I'm not sure I understand the question. Like which API? Like there are two different APIs. There is the instrumentation. Like here, there are two different kind of API. There is the attach API, and there is the instrumentation API. So the attach API will be run like once. It's a one shot. And once the agent has been loaded, then every time a new class change has been detected, it will reload it. So I don't know if I answered the question.
Okay. Instrumentation API.
Instrumentation API. Yeah. That's the point. So imagine that that's the point. I will show you the issue. The thing is, imagine that here what we want to do is we only want to stream the bytecode that has changed. So here there is a filter, and only when we detect a change is the app reloading the bytecode. So if there is no change, nothing happens. So nothing happens, no problem with runtime.
So it is an atomic operation, right?
What is atomic operation?
Okay. When bytecode change detected, just updates this bytecodes on target JVM, and then finished.
And then finished.
Yeah.
Now, the most important part is the demo. So here I have my production application. So I have this main class. I create a new Tomcat. I add a context, which will be at the root. And I add a servlet, which is mapped to hello. For some reason, here I need to do tomcat.connector. It's a bug in the current Tomcat implementation. And I create the server, and it's done. So here I have my hello servlet. It tells me, hey, hello world. And I just run it. This is the main. So, and very important, I run it directly. I don't run it in debug. I run it normally. Yeah, let's try. Wait, let's try to. So here, this is what is shown, right?
Yes.
Okay, so far so good. I just created a servlet, said hello world, run Tomcat, everything was as expected. Now what I want to do is to run the jet job. And the jet job basically is this one. So I'm using the API. Here I'm using Kotlin. I'm really sorry. I hope it's okay. I'm creating a new jet instance. And with the job config, I will create a new job with the pipeline. And the pipeline will be reading from the class file system, and I will just write it in the logs, and I will filter it. So basically what I'm doing, this is the important part. Because every time it will send me, hey, here is this class, here is this class, here is this class. I don't want to send class updates when there is no update. So what I will be doing, I will be checking if this bytecode array is already part of the IMDG map. And if it's the same one, then I say, there is no need to send it again because it's already there. So here I'm checking that basically it's the same or not. And if it's not the same, then I will use it to have an entry to have both the class name and the byte array, and I will write it down to IMDG. So I launch this one. So now I'm launching Jet, and it's not refreshed, but believe me, on my machine, it tells me that there is it does its job. But basically right now, nothing is happening because the production application has no clue about what to do because it's just like displaying a servlet. So the next step is actually to go to the update agents. And the update agents will be using this existing Jet instance, get a client out of it, get the place where Jet basically puts the byte codes, and every time there is something that gets refreshed, then I register a listener, and every time there is an update event, I will get the class out of the key and get the new byte array out of the value. Okay, let's get it back. Perhaps, no, it's making it worse. Here, here. Okay. So here on the lower half of the screen, you see that actually there is this streaming stuff. So every now and then it sends this event. And of course, because so far nothing has happened, then it doesn't do anything. So I was saying that here I'm getting the name of the class, and here, just here, I've got the byte array. And now the final stuff is to send the agent, and the agent itself is super stupid. Not the agent, but the attach of the agent. So I need to get the main PID. So this is the last step. So in the main method, I'm telling the virtual machine to attach to the production JVM. And because I don't want every time to say, oh, I need to check the PID of the production JVM, I have this method, get main PID, and it does, it gets all the processes. And basically, I get the one that where the command line ends with the main stuff, which basically is the main one that I launch in the beginning. And afterwards, I will load the agent with the path. And here the path is set in stone because I didn't want, I know where it is, so I don't need to have to try to be smart. And here I will be doing the attachment. And I don't know, it will be seen off the screen, but basically it will launch the JVM, attach itself to the production JVM, and just afterwards, because it has done its job, kills itself. So it's not refreshed, but again, you must trust me. Now what I will be doing, I will be changing the source code. So here I have completely unrelated projects. It just is like the mirror of the Hello servlet, but it's not the one that is actually in production. And I will change that. So I will say, hello, Istanbul jog. No, and because now I speak super good Turkish, I will say selam. And I will compile only this one. I will compile only this source one. Where is my build modules source? And normally, if I go back here and I refresh, this is updated. So I hope that you are like super amazed, because it's very hard. I would be in a conference room, I would see your faces, but here I don't see nothing. So let's hope that you are super amazed. And let's continue the presentation. So obviously there are limitations. Do you see my presentation now?
Yes.
Yes. Okay. So the first one is, if you have been doing traditional deployment of application, in general, you build your jar, you set a version, and then you say, I know that version x.y.z is in production. When you start doing continuous deployments, then it's not the way to go. You cannot say, hey, I have version XYZ, because basically you have like perhaps one version per hour or one version per 10 minutes. So it doesn't work. So this no tagging stuff is part of the continuous deployment model. So it's not really a limitation. You must need to change your mindset. Obviously, the instrumentation API allows for loading existing classes, but it doesn't allow you to load new classes. However, I'm pretty sure, and I don't know the whole JVM, but I'm pretty sure it's doable right now. And then finally, you must just handle the class loading magic. And depending on what version of Java you are using, it might be easy or a bit harder, especially after the modules, but it's still possible. And then the Redefine classes method has some limitation in itself. So you cannot add, remove, or rename fields or methods, change their signatures, or change the inheritance hierarchy. So it's limited to basically changing the implementation of the classes, which is still good, but you cannot do everything. And of course, from that, you can have some improvements. So instead of streaming from your machine, which would be not super great, you can stream from the CI pipeline. So basically, you would still be doing continuous integration. Like your commit would trigger a change. You would do everything, and in the end of the pipeline, you would have a folder with this new bytecode, and this is the place where the jet will get its classes from. What you could do is, because now you don't have this tagging anymore, you could add additional metadata in each class. For example, you could have like a git tag or whatever. So if you want to have this tagging stuff, then you can add that, and it's part of the improvements that you can do. So thanks for your attention. You can read my blog where I publish weekly blog posts. You can follow me on Twitter, of course, and I will be very happy if you do. And finally, you can get the repository and play with the codes by yourself, and check that it works also on your machine. And now perhaps there is some time for some questions.
Yeah, I have a question. So This is an experimental approach, right?
Yes, this is very experimental. This is for fun.
Okay. There's another question. It's about Hazelcast Jet. I wonder if Hazelcast Jet has a particular serializer, deserializer implementation like Kafka streaming.
So we by default, that Jet is independent of Kafka, and basically the default serializer in Jet is the one that is found in IMDG, and basically we are relying on Java serialization. But you can plug your own serializer, so you can have JSON serializer, you can have XML serializer, and nothing prevents you from serializing your object to Kafka as well.
Okay. So we don't have another question. All right, we have another one. Why this bytecode operation is not acted by JVM instead of developer? For example, it handled by SDK, which name is Instant Run in Android.
First, I don't understand the Android's parallel because I'm not an Android developer. The second is it has been very hard since the beginning of Java to do hot reloads of bytecode. In general, in order to do hot reload of bytecode, you must use hotspots and you must run in debug mode. However, you probably don't want to run in debug mode in production. So this is one way to handle this hot reload stuff. So you could, for example, send patches, hot patches, directly to production without any downtime.
Okay. There isn't any question. So thank you for your presentation.
Thanks for the invite. I hope you liked it. I hope it gave you some ideas. Sonra görüşürüz.
Görüşmek üzere. Teşekkür ederiz.
Bye bye. Have fun. Have a good evening.